Okay, so we will start from this application of the Fourier transform for the continuous and discrete time signal, and Laplace transform and Z transform, and also you study the RMS value, average value of any general periodic waveform. This part mostly you also cover in the network theory. Okay, mostly you cover the how to calculate the RMS and average value of a signal in the network theory also. So we will be mostly focusing on this part. The remaining part definitely we will be covering in the network theory. So whoever teach you network theory, they will definitely cover, no doubt about it. Okay. So if you are from electronics engineering, then your syllabus will start from Fourier series and Fourier transform, sampling theorem, and application. Discrete time Fourier transform, DFT, Z transform, discrete time processing of continuous time signal, LTI system, definition and properties, causality, stability, impulse response, convolution, poles and zeros, frequency and group delay, phase delay. So you can see that there is a slight difference in the syllabus of electrical and electronics. But to understand these topics, Fourier series and Fourier transform, DTFT like that, we have to start from the basics, which is even not mentioned in your electronic syllabus, but it is by default there, and the question comes from those topics as well. So we will start from the signal. What is signal? So if anybody asks you the meaning of signal, so in general we can say that anything which carries the information. Like if I want to say hi to you, I will just wave my hand, and it is another way of giving you the signal that I want to wish you, I want to greet you. Okay, so similarly, if you want to say like stop, okay, then you can show just your finger, palm, and you can ask somebody to stop. Like in the cricket match, we see that if umpire wants to give us the information that the batter has hit the six, just he shows the signal. Okay, he gives the signal when he just take his both hand up. Okay, so in this way we can say uh, that we have, okay, we can say that we have a signals. Okay, okay, so there are two types of signal. As you can see in this particular syllabus, there is a two type of signal: continuous time signal and the discrete time signal. So continuous time and discrete time, these are the two type of signal which we need to discuss. So in general, if I say what is the definition of signal, so you can say that signal is a physical quantity carrying some amount of information. Okay, any physical quantity which carries the information is called the signal. So signal constitute an important part of our daily life. Signal is also defined as a single value function. Okay, single value function. This is a, we can say, a single value function. Okay, single value function of one or more independent variable. Okay, a single value function of one or more independent variable which contain some information. A signal may also define as any physical quantity that varies with time. Any physical quantity that varies with time. This is the one of the way of representing the signal. This is one definition. You can explain signal is nothing but a physical quantity which carry the information. You can explain a single valued function of one or more independent variable. You can also say signal may be defined as a physical quantity that varies with time. So here you can see that there is a stock market information which is giving us information that at 11 o'clock the market is going upward direction, at around 3 o'clock it is going in the downward direction. So you can see that this is giving us the information, and this physical quantity is changing with respect to time. Similarly, you can also say that the political party performance in the year 2004, there were 46 seats. Now it is 2019, it has 60 seats. So it is again rising over the year. Right now we can say 46 to 60, there is a jump in the number of seat, and which we can say that which is changing with respect to time. So in this way also you can define the signal. Signal may be a function of time, it may be function of space, or anything which is independent variable. Okay, it can be function of any independent variable. Usually we take the time. When we study this course, we always take the signal as a function, or any physical quantity which is a function of time. Okay, so signal may be represented in both the domain. One is the time domain, and we can also convert that in the frequency domain, and that is the purpose of your Fourier transform and the Laplace transform. Basically they convert the signal from time to frequency domain. Okay, human speech is also an example of signal. Current, voltage are also example of signal. A signal can be function of one or more independent variable which we have written. Okay, signal can be one, it can be dependent upon one independent variable, and it can also depend upon two independent variable. If it is depending upon one independent variable, then it is called one dimensional, and if it depends upon the two variable, then it is called two dimension. Okay, is it clear? Is it clear? Anything which you want to ask here about the signal? There are multiple ways to define the signal, and I have told you many of them. Clear? Okay. Now, as I said that the signal mostly we will take as a physical quantity which varies with respect to time. It may be depend upon temperature, it may be depending upon the space, but in this course we have to take as a function of time, right? Now, the signal can be two types, analog signal and digital signal, or you can say that in the continuous signal and the discrete signal. The digital signal are those which you study in the digital circuits, and also you will somewhat study in the communication engineering. Okay, so in the communication system you will talk about the sending the digital signals using some modulation technique. Those are the topics which you are discussing under the digital communication, where you will take the data, your signal, in the digital form. So this is you are going to study in your communication system. And in this course we will again focus on these two things mainly. That is, first is continuous time signal, and the second one is the discrete time signal. What do you mean by the continuous time signal? So continuous time signals are those signals which are continuous in time. Okay, that is nothing but all instant of time. Signals are defined for all instant of time, like this. Signals are defined for all instant of time. I'm just representing the random diagram. So you can see that this is suppose x of t, it is a physical quantity x, and the independent variable we have taken time. So it is continuous at all instant of time. You can see that it is defined everywhere in the time axis. And discrete time, let me write here. Signals are defined for all instant of time. For all instant of time. Signal for all instant of time. Okay. So after this, okay, now it is coming. All right. Okay, so this is the x of t, and it is defined for all instant of time, and there is a discrete signal which is defined only for the discrete value of time, discrete instant of time, something like this, discrete instant of time. It may be positive, it may be negative. So this is 0, this is 1, this is 2, this is -1. This is n. In the discrete time, we represent it by n, x of n. Here the value is 0. The value may be somewhat minus. So there can be positive, there can be more positive. Like the value we represent like this. Suppose this value is 1, this value is 4, this value is -3, like this. So these are the values. The green one are the values of the signal at the different time instant. So these are only the integer value it takes, only integer value it takes. So it is called discrete instant of time. Okay, so it is called discrete instance of time. Okay, discrete instant of time, like this. Now, these discrete signals have more, many ways to represent. So these discrete signals, we can represent it by many different ways. So we can say there are 4 ways. Okay, there are 4 ways to represent discrete time signal. Okay, there are 4 different ways to represent the discrete time signal. First is called graphical method. Continuous time signals are represented only in by one way, so it is called graphical representation. Second one is the functional representation. And third one is tabular representation. And fourth one is sequence representation. Okay, so these are the 4 different ways. So how you will represent? Suppose the signal is, if first way I am representing the graphical representation, which we just did, Basically, it is like at 0 we have taken 0. So let us say this is 3, this is 1, this is 2, and it is also 2, and let us say this is minus of 3. let's say -1. Okay, see, this is x of n, okay, and this is n. Because it is discrete, in the discrete time we represent it by n. Now this is 0, this is 1, this is 2, this is 3, this is -1, and this is -2. Okay, now value is represented by the dot. The dot I am representing it by green. So this is 0, here it is value 3, this value I have taken 1, this value is 2, this value is again 2, and this value is -1. So these are the value, and this is the first way of representation, that is graphical representation. Now, how do you write the functional representation? The functional representation is like this: x of n. It has the values like -1 for n equal to -2. For n equal to -2, the x of n has the value -1. And now at n equal to -1, it is 2. For n equal to 0, it is 0. And for n equal to 1, we have 3. For n equal to 2, we have 1. For n equal to 3, we have 2. Okay, so this is called functional representation. Now the third one is called the tabular representation. So in the tabular representation, we have to make some table kind of thing like this. And here we will write n, we will change n, and the value of xn. What is the value? This is -1, sorry. The starting point is -2, okay? The signal is starting from -2. So it is -2, then -1, then 0, then 1, and then 2, and then 3. -2, this has the value -1. At -1, it has value 2. And then at 0, the value is 0. At 1, the value is 3. Then 1, then 2, like this. So this is the tabular representation. Okay, this is the tabular representation. Now the fourth is the sequence representation. In the sequence representation, we write in this way, that again you have to write starting from the negative side. So in the negative side it is -2, but in the sequence representation you have to write only the value of the signal. So the value of the signal starting from -1. So it is -1, then 2, then 0, then 3, then 1, then 2. Now how will you identify that which is the n equal to 1, which is n equal to 2, or which is n equal to 0? So to show that n equal to 0, we mark this arrow. This shows the origin. This shows the origin. The arrow mark upward denotes the n equal to 0. When no mark is indicated, okay, when no mark is indicated, then by default first one is your n equal to 0. Indicated, the first term corresponds to 0. Okay, so if it is n equal to 0, then the left one is n equal to -1, then it is n equal to -2, and the right one is n equal to 1, n equal to 2, n equal to 3, like this. Okay, so right side there is a positive value, in the left side there is a negative value. So these are the 4 different ways of representing the discrete time signal. Clear? Okay, now we will have some operation on the signals. You might be heard about number of signals like unit step signal, unit ramp signal, delta function, sinusoidal, exponential, signum, and ramp parabolic signal. So there are multiple signals. Okay, But those signals we will discuss later on. But right now we are discussing the basic signal operation. Okay, irrespective of the you are knowing the signal or not, we can understand these basic operation on the signal. Okay, and obviously this would be our first lecture also in the signals and system. We will be discussing these things only. So yeah, so there are a number of operations. First is amplitude scaling, second is amplitude folding, third is time shifting, and time shifting may be time delay and time advance. Time scaling can be signal expansion and signal compression, and time folding. Okay, time folding also. So let's begin with the amplitude scaling. So amplitude scaling means you are having the signal x of t and you are scale it by factor a, then the signal will be written in the form of axt. Okay, the axt. Okay, so if you have a signal and you want to suppose amplitude scale, then just multiply it by some factor. Then the amplified or not amplified amplitude scale version is called AXT. Okay, now what is the working rule? If the signal is XT, then simply multiply it by amplitude scaling factor A. Okay, like you can understand this by having some practical example. Suppose when you increase the volume, when you increase the volume in the TV or in any mobile or something, or there is a knob of uh, increasing the volume in some speakers, so that is nothing but the amplitude scaling. You increase its amplitude. Okay, when you decrease it, amplitude goes decrease. It is not like when you change the knob, it is not like that you are changing the frequency or something. You are basically going to change the amplitude. Okay, so the shape of the sound will remain same. Okay, suppose the sound is like this, then when you have x of t like this, or suppose you increase the volume, then its amplitude will get increased like this. Okay, only the amplitude get increased, it will not change the shape. The shape is still the same because I'm writing roughly, I'm drawing roughly, so it may be a little bit up and down, but you can understand that this is the amplitude now and it was the amplitude previously. So after amplitude scaling, this will be the effect of scaling it. Okay, when you amplitude scale, the width of the signal remain unchanged. Okay, you can see that this width and this width remains same, this width and this width remains same, like this. Okay, okay, amplified and the amplification also, you have this application in the wireless communication. Also you have amplitude increasing, and signal conditioning also you can do. And when you increase the brightness of any image, that is also an example of amplitude scaling. Okay, understood? Now amplitude folding. What do you mean by amplitude folding? Amplitude folding is like x of t, means you are just changing the amplitude from positive to negative. That's it. Nothing gets increased, nothing gets in the time also there is no change. Only the positive will become negative and negative will become positive. Okay, when there is a audio distortion, we can make it negative. Like when audio signal exceeds some limit, then peak of that gets folded back. That is how we can use. In the loudspeaker, we use this. Okay, so in some time in the pictures, too much light means the pixel values exceeded maximum value. So there also we can use the inversion amplitude folding, that is also known as inversion, because you are inverting positive to negative and negative to positive. Amplitude folding operation can be viewed as amplitude scale by factor -1. Okay, here you are increasing the amplitude by a factor a. Now if this a become -1, then it will be amplitude folding. Now for the time being, this is one of the example we are taking. This is 5 times of xt. You can see that this signal x of t, it is a continuous time signal because it is present at every instant of time, all instant of time between -2 to 2. So now you have to amplitude scale by factor 5. So as we see that only amplitude gets multiplied. So what was the amplitude previously? It is 2. Now you are multiplying it by 5. So when you amplitude be multiplied with 5, so the amplitude will become 10. Okay, this amplitude will become 10. Okay, now the amplitude become 10. This is x of t. The shape is same, but now this is 5 times x of t. This is -2. This is 2. We have got this. So this is nothing but the first one. 5xt means the amplitude is increased without changing the shape. One more thing that we have written, that area will be changed by the factor by which you are scaling it. So previously you can see that this area of this rectangular signal was, the width is 4, and the height is 2. So the width area is length into breadth. You can see this is 8. Now this area is again this width is 4 into the height is 10. You can say this is 40, or you can say 5 times of 8. So this 8 is the previous area, and this 5 is the scaling factor. Let us say k right now, because area I have taken a. So this is area and the factor I am taking k. So new area, the new area, we write like this, new area. So new area is k times of old area. Okay, so k times area, old area, and this is a new. So new area become k times of old area. Clear? Okay, now similarly you can consider this -2xt. Now when you multiply this 2 by -2, it will become -4. So when it will become -4, how do you draw it? So it is the same signal, but now it is -4. So it will vary from -2 to 2, and this is -2 times of xt. This height is -4. Okay, so again, as we have made one conclusion that the new area is k times of old area. That means k is -2 and old area was 8, so the area will become -16. Now can area be negative? You will say no, definitely not. This negative sign indicates that the graph will be below the time axis. Negative sign indicates that graph will be below the time axis. Okay, if you are getting the negative area, that means it is below the time axis. Or you can also say that if you are having any signal below the time axis, you have to take its area negative. Okay, don't consider positive. Like suppose this is the triangle and this is rectangle like this. It is given -2, 0, 2 and 4, and this is value 1 and this is, let us say, value 2. Now if I ask you to calculate the area of this entire graph, then what will you do? You will take the area of this. You will say, sir, 1 by 2, base is 4, height is 1, the area is 2. You will say, sir, area is width into height, height is 2, because the width is 2, height is also 2, area here is 4. Now what is the total area? You will say, sir, total area will be 2 plus 4 becomes 6. But this is wrong. This is wrong. Okay, because the area below the time axis you should have taken negative. That means -4. So it will be 2 minus 4 equal to -2. So now this -2 shows that the resultant area will be negative. Means magnitude will be 2 only, but this shows that the negative region has more area than the positive region. Okay. So this is how you have to take when you calculate the area in the signal. Below the time axis, all the signal area will be taken negative. Now coming to the next property, time shifting. Now, how do you understand the time shifting? Time shifting means, suppose our class time is at 9 p.m. Okay. Time shifting is two parts, time delay and time advance. Now I'm saying that, let us say our class timing is 9 p.m. and if I start it by 9:10, like it happened today because of the audio issue and signal sharing, screen sharing. Now suppose I started at 9:10. So what you will say, it is a delay or advance? Definitely you will say, sir, you are delaying the class, means the class started late. Delay means starting late. I started class late by 10 minutes. So the delay. Now suppose I would have started at 8:50. Then what happened? It is advance. I have joined the session in advance. Actually, I had joined, but the audio issue I could not understand because until we go live, I was not able to check it. Or I can say that there is one more thing which I missed today, this time, that I was not entering into the session because it is not enabled in my laptop. It was there in the mobile, and I was in the beginning also I was not able to share the screen. I told you that I have to re-log in it, and that is also the reason that I was not able to check the audio. But most probably we will be able to solve it from the next time. 99%. 1% again I will take chance to go live and then check, but still I will not do that because actually when I'm putting off the mic, then we got disconnected, like just happened. In between the session there was a 30-40 seconds I tried it, and I was not able to do the setting that it is not taking my voice from directly from the laptop. It is taking my voice only from the mic. So when I connected mic again, then you are able to listen me. And I think the audio is very clear, right? Because it is from the mic, so there is no noise, because it is a noise cancellation mic, so it is giving you the good quality audio. So if I come from this mic, then definitely you will listen the voice like this only. So, and from the laptop mic, maybe there may be some noise, but it has not happened in previous year because I used to take from the laptop mic only. But in between these 3 to 4 months, when the session was not there, the laptop setting has changed, and that is why it is taking voice, not taking voice from the laptop. Now I have to do the setting again. Okay, coming back to this, that if I will start my class from 9:10, you will say, sir, you are starting late. That means you are delaying the class. And if I start it early, sir, you are starting early and we are not able to join on the time, right? Usually this is our time in the regular batches, right? You might have finished one or two subjects. So this is 8:50. Right now for the today's session, it is early. So you will say, sir, it is advanced. So now what you understood from here, that if I delay the signal, actually the signal will shift towards right. Okay. So if I ask you to delay the signal, you will shift the signal towards right. If I ask you to advance the signal, you will shift the signal toward left. This is the main reason that I show you this graph, kind of, that why we say that delaying means shifting right, because when you delay it in the time, it is actually shifting right. Okay. Now mathematically it is written in this form: x of t, if you want to delay it by a, then it is x of t minus a. So to delay a signal x of t by a, argument t is replaced by t minus a. Simply replace the t by t minus a and you will get your delayed signal. Time delay means shifting right on the graph, we have understood. Time delay means starting late, that also we have understood. Now shifting left also, let's understand. So time advance means shifting the signal towards left, and replacing the t by t plus a shows the time advance operation. Time advance means starting early. Time advance means shifting left on the graph. Okay. Understood? Okay. Now, if you want to delay it, first of all, let's understand if I want to write it in the functional representation. How do you write? X of t. How do you write this signal x of t? Functional way. In the functional way, we will write it is having the value 2 from minus 2 to 2. From minus 2 to 2. Right? Now, if and 0 otherwise, and other places it is having 0. Okay. So this is 0, this is 0, and minus 2 to 2, it is 2. Got it? Now, I said that replace the t by t minus 2 and you will get your delayed signal. So t by t minus 2. Replace the t by t minus 2 everywhere. Okay. Now, 0 otherwise, but if I want to write this, because this is showing that the axis is t minus 2. If you take the axis t minus 2, then x t minus 2 will be like this only. X t minus 2 will not change. X t minus 2 will not change its position if you take this axis t minus 2. But we know that we always take the time axis, not t minus 2 axis. So what you need to do now? So now you will represent this as a t. So what you will do, if you want to replace this minus 2, just add plus 2 in this inequality. So in this inequality, when you add plus 2, then minus 2 plus 2 becomes 0, and this will become t, and 2 plus 2 become 4. So 0 to 4. So this will be the graph, that is starting from 2, 0 and end up at 4. 0 to 4. This is now the time axis, x of t minus 2. X of t minus 2 and the height is 2. Clear? So now what you understood from here, that if I want to delay the signal by any factor a, I will just add that factor in the time axis itself. Suppose I would have added this. What is the time factor here? We want to delay it by 2, right? So that factor is 2. So if I would have added these 2 in the whole time axis, so these are the numbers I have, so I would have added like this. So this is coming 0, this is coming 2, this is coming 4. So I would have drawn it before writing this only. So no need to write this part. Only what you need to remember, that whenever we want to delay the signal by some factor a, then just add the factor in the whole time axis and you will get the result. So if I add plus 2 here, it is 0. So means now this signal will go up at 0 and it will remain constant from this 0 to 4. It will remain constant up to 4, and at 4 it will go downward, and at 4 it will go downward. So you can see that here the result we have drawn, at t equal to 0 it is going up and it is constant from 0 to 4 at 2 and again going down at 4. Okay. So now what will be the value of the signal or range of the signal when a is 5? Can you tell me? When a is 5, what will be the range? So when the a is 5, this is plus 5, this is also plus 5, this is also plus 5, it will be 3, it is 5, it is 7. So it will start from 3 and go up to 7. So it will start from 3 and go up to 7. So at 3 it is going upward and at 7 it is going downward. So this is 3 to 7, x of t minus 5 is t. And the value is 2. So area also will not change. Area will also not change because the width is and height both are same. The height and width both are same. You can see that area is 4 into 2, 8. Here also you can see that the area is 4 into 2, 8. And here also you can see this area is 4 into 2 become 8. So the area is not going to change by shifting. So shifting does not affect on area of the signal. Does not affect on area of the signal. Now shifting left. So again, as I told you, you can just write it x of t. It is 2 from minus 2 to 2, 0 otherwise. But now I want to write t plus 2. What you will do? You will just replace the t by t plus 2 and 0 otherwise. Okay. So or we can write if, because we know that this axis is not possible, t plus 2 if we don't take, so we will just take minus 2. So when you do minus 2, then it will become minus 4. This is t and this is 0 and 0 otherwise. Okay. Now minus 4 to 0 you can draw. So it is same way, it is in the same way like you did in the delay operation. So t plus 2, you don't need to write all this again. Okay, what you need to do, you should have taken you should have added this -2 in the axis itself. So this is -2, this is -2, this is -2, this will become -4, this will become -2, this will become 0. So it is going in the upward direction at -4 and downward in -4 and downward in 0. Okay. And x of t plus 3, this is t plus 3 means you need to add plus 3 here, the whole axis. So it is plus 3, oh sorry, minus 3, sorry. Because when you will equate it, it will be t equal to -3. So the factor will be -3. So -3, -3, this is -5, it is -3, and it is -1. So signal will start from -1 and it will go up to this. Okay. Again, you can check the area will not change. This height is 2. And out up to this point, okay. So what is the use of this time delay? Can anybody tell me? Okay, so actually delay means when you say something here and like you are talking on mobile and you are saying something and your friend is replying it little bit delay. So there is a small gap. So that is called delay. Like in the echo sound, when you clap or when you shout near the mountain, you listen the signal after some time delay. That is also the delay. Okay, switching on the light, when you switch on the light, it actually lit up after some delay. Okay, so delay means the same signal but it is coming little bit late. Now we have the last operation, we can say this is the time scaling and the signal expansion and signal compression we will complete, and then we will wind up this session because this is a demonstration. Otherwise we would have taken the 2 hours class. Okay, so the time scaling, mathematical representation of the time scaling is x of t is represented by x of at. So it is time scaling, and replace the t by at and again do the same thing which I told you just now, that if to draw the time scale signal, what you need to do to draw the time scale signal, just divide the coefficient of t in the whole time axis. Okay, like in the delay I told you to add the signal, in advance I told you to subtract that whole factor in the whole time axis. Similarly, to scale it, just divide the whole time axis by factor a. So time scaling means representing the by mean a means t will be straight replaced by at. So t is replaced by at. Time scaling factor, if this a is less than 1, then it corresponds to expansion, and if this a is greater than 1, then it's signal compression. It corresponds to signal compression. Let's understand it by this example. I told you that x of t is -2 and -2 to 2, it is 0, otherwise okay. So x of 2t, again what you will do, -2 replace the t by 2t. I said this is 2 and this is 0 and this is otherwise, and or else you can write this t axis we don't know, so we have to divide it by 2. So when you divide it by 2, this is +2, sorry, when you divide it by 2, it is -1 and it is 2 and it is 1, okay, and 0 otherwise. So what you observe from here, you observe that this t is ranging from -1 to 1 now. So previously it was -2 to 2, now it is -1 to 1. So basically you can say that the signal is compressed. Okay, the signal is compressed. Okay, the signal is compressed like this, x of 2t. Okay, so the signal is compressed. So obviously the area will change. Okay, the area will change here. The area is now 4. Previously the area was 8. Now we will make some rule, don't worry. Okay, so one thing that it is compressed, as you can see that this factor a is 2 here, which is greater than 1, so it is compression. We have written that if a is greater than 1, the signal compression will be done. So here a is greater than 1, so here the a is 1 by 2, a is 1 by 2, which is less than 1, so definitely there will be expansion. Okay, now when you will see in the same way, by which factor? By the factor 2. So you will be expanding the signal by factor 2. So simply just divide it by the factor. What is the time factor you have? The time factor you have is 1 by 2, or scaling factor is 1 by 2. So scaling factor is 1 by 2. So divide the whole axis by coefficient of t. Divide the whole axis by coefficient of t. So when we divide it, we will get -4. Here we get 0. Here we get 4. So it is -4, 0, and 4. Okay. In the previous case, we divided it by factor 2. So when we divided it by factor 2, it was -1, 0, and 1. Okay. Now the area is 8 into 2, which is 16. Okay. Understood? So what is the conclusion here? The new area is old area divided by the factor a, right? So if the factor is 2, in the first case the factor was 2, the area, old area was 8, so 8 divided by 2 become 4. And when the factor was 1 by 2, 8 divided by 1 by 2 become 16. So in this way, we can say that the new area, whenever we perform the amplitude scaling, time scaling, whenever we perform the time scaling, the area will change by that factor a. Whether it is expansion or compression, the area will be divided by factor a. So if a is greater than 1, the signal compressed. If a is less than 1, signal is expanded, and accordingly the area will change. Time folding. So time folding is just the scale it by a factor -1. Okay. So time folding means rotation of the signal about the vertical axis, because the positive time will become negative, right? So if suppose I want to draw this, and I'm considering only third part, because this part you can do by yourself. We have done it. This is time compression, this is time this is time compression, this is expansion. Okay, this is the factor a, which is less than 1, so this is expansion, this is compression. This you can do, and this I am doing for time folding. Again, what I told you, whatever be the coefficient of t, just divide the whole axis by that value. So the coefficient of t here is -1. So you can say you are scaling it by factor -1. So what is the rule of time scale? Divide the factor a in the whole axis. So the whole axis is divided by -1. So this is -1, this is also -1, this is also -1. So this will become +1, this will become -1, this will become -2, this will become -3. And that's why we said that it is nothing but the folding the signal vertically, holding the signal vertically or rotating the signal by 180 degree. So this will become, where this was upward, okay, when there was this one upward, it is now at positive side. This is positive side, and now it is constant, and like this it is. Okay, so this 0 will become 0, and this -1 become +1, and this triangle peak, this peak triangle was previously at +1, now it is at -1. So it will be at -1, it is at -2, it is at -3. This is x of minus t. This is x of minus t. Any doubt? Okay, so I had just divided the whole axis by factor -1, and I get this signal. There will be no change in the area because the width and height is not changing, only the axis is changing, so the area will not change. So the time scaling does not affect area. Time folding, I should say. Time folding does not change area of signal. Okay. So guys, I think we have discussed everything which I wanted to discuss today. So let's wind up the session. Rajshekharan, if you want to ask anything, just let me know. And if not, then also you let me know what is your branch at least. And this is the contact information. If you want to share this with your friends to join this course, they can join from here. And when you are more than one people, definitely there will be more motivation to prepare for it. So please share it with your friends also. And don't forget to subscribe the YouTube channel of IGC. So Rajshekharan, you want to say anything? At least say yes or no. Okay, that's great. So how many subjects you have finished with IGC? Network theory done? Okay, two right now. Digital and math is going, and how many completed? Two right now you have completed, or two subjects are running? Means any subject you have completed? Okay. So you are, when you joined? Okay, great. And are you working? Okay, you were working, but now you have finished. You might have resigned to prepare for GATE, right? Good, that's good. Okay, so prepare well, Rajshekharan. We have produced good rank last year, and now the team is working very hard to to make result from the students. So anything, anywhere, you should be able to ask, and be active in the class also, because when, if suppose I ask, if you will reply it, definitely it will be more interactive, rather than having one-sided session. It will be more interactive session. So try to answer if you suppose calculated, or if in general I am asking, so try to answer, because it makes class live. Otherwise, it is like one-sided. I'm saying, I don't know when anyone is listening or not, like that it happens. So don't be like this. Be active and participate every time. Okay. Okay, so thank you. Okay, thank you. That is important. I should be knowing it, that you are from instrumentation. That's fine. Okay, thank you.